Hello, welcome back to Alien Space Education. My name's Andy from Space for All. I'm your host today, and today's fantastic episode is all about Neptune. Before we start, I'd just like to say thank you for listening, and please remember to share this with anyone else who loves space, because I want everyone to enjoy this. So please share it as much as you can. Remember, support through the Patreon if you wish to support me, and don't forget to check out my website, Space for All Education, to learn more about the amazing universe we live in. Okay, so let's buckle in and dive into the world of Neptune. Neptune is a quite unusual planet. So it was first discovered in 1846. It's the third most massive planet in the solar system. So it's really, really big. It's bigger than Uranus, yet it's further away. It's known for its deep blue colour, which is due to the presence of methane in the atmosphere. So methane, a lot of it turns blue. It is the only planet to be discovered through mathematics. So maths is really crucial rather than direct observation. So rather than us trying to look through a telescope and say, yeah, there's a planet, we actually had to mathematically calculate it and then look for it. And because of its distance, because it's so far away, it's still a mystery to us, and we've still got lots to learn about it. So we're going to cover a little bit about it, okay? Neptune's atmosphere, starting with the atmosphere, is dynamic, a turbulent place, composed primarily of hydrogen and helium, with methane given a distinctive blue hue. Now, how hydrogen and helium and methane, the combination to give it the blue hue, we're not 100% sure yet, but the amount there does give that. It also experiences really, really fast winds. So we're talking massive, really, really fast. It'll blow us over and then to the sun. The wind speeds, on average, reach up to 1,200 kilometers an hour, or 13 miles per hour, 1,300 miles per hour. That's faster than a car. That's really faster than a plane. So it's going super fast. These winds drive the planet's large storm system. Now, it has something called, where Jupiter has a giant red spot, this one has a giant dark spot. A massive storm, but it's a dark spot rather than the giant red spot we saw on Jupiter. Voyager 2 is the only spacecraft to have visited Neptune. It observed these storms during its flyby in 1989. We're now 2024. We haven't been back there, so we need to go back there. Neptune's atmosphere is surprisingly active, with frequently changes, new storms formation observed by both Voyager 2 and most recently telescopic observations, because since 1989 and today, our telescopes have got bigger and better and everything like that, so we can see it and we can see the planet changing, its atmosphere changing. So that's how we know these things. Okay, so its tilt and magnetic field is also very complex. Neptune's magnetic field is another intriguing aspect. So unlike Earth's relatively simple magnetic field, Neptune's tilt is about 47 degrees of its relative position. So it's quite a long way off its centre. We're very small. Neptune is quite big. This system is highly complex, dynamic magnetic aspect. These interactions between Neptune's magnetic field and solar winds create auroras that are both intense and unique, adding to the planet's mystery aurora. So because it's tilted so much, and it is still getting solar storms, that's given the solar auroras. So these magnetic storms that the sun generates are going all the way to Neptune. It's giving solar auroras, and it's magnificent, but it's 47 degrees off its axis. That's a long way. We're only a small bit. That's a long way. So there's still a lot to know. We don't understand what its core is or things like that, so we've still got a lot to learn. Beyond that, there's the moons of Neptune. Neptune, as we know at present, has 14 moons, and the most prominent one is Triton. Triton is unique for several reasons, and this is really interesting, so pay attention. It's one of the few moons in the solar system that orbits a planet in the opposite direction to the planet's rotation. So Neptune's spinning one way, this moon is going the opposite direction, which is really weird, and it's called a retrograde orbit. Triton is also one of the coldest objects in the solar system, with a surface temperature of about minus 235 degrees, colder than your freezer. Or in Fahrenheit, that's minus 388. Voyager's 2 encounter with Triton revealed geysers of nitrogen gas erupting from beneath its surface. These guys suggest Triton has a subsurface ocean, or at least some form of internal activity. The Triton's surface also features vast plains of frozen nitrogen and a series of dark streaks, possibly caused by interactions with geysers plumes and the surface. Basically, it's an ice world. It has an ocean or something underneath the ice, which is allowing this pressure to build up and these geysers to shoot out. So great that Voyager 2 saw it when it flew by it. So these geysers are going to be massive, hugely massive. And remember, we haven't been back there since 1989. So what we're seeing through our telescopes shows you how powerful the telescopes are to keep observing this, but we still don't know what's causing them. Going on from there, the rings of Neptune. Neptune has rings. Neptune's rings are less prominent, shall we say, than Saturn's. They are still fascinating. These rings are faint, composed of dark material, likely made of particles of a mix of ice and rocks, probably more rock than ice, because ice will reflect it unless it's made of something else. These 5 nodes only has 5 rings, and they are thought to be relatively young in astronomical terms, possibly formed from debris of a captured or shattered moon, or maybe asteroids, because it is still close to the Kuiper belt, which is also where possible Triton came from, which is why it is in a retrograde orbit. So there's still a lot to learn and figure out. Voyager 2 had a brief encounter, so let's cover that a little bit. In 1989, when it did pass Neptune, it provided the first close-up images and detailed about Neptune's atmosphere, rings, and moons. This encounter was brief but incredibly valuable, offering a snapshot of Neptune that continues to be analysed and studied. So even stuff from 1989, that's 30 years ago, we're still studying today. Maybe with your help we can study it further. So despite the distances and challenges of studying it from afar, Neptune remains one of the most intriguing planets in our solar system. Its dynamic atmosphere, unique magnetic field, its fascinating moons offer a glimpse into the complexity of the outer solar system. Further missions are desperately needed to reveal what secrets Neptune holds. I thank you for joining me for this short little talk about Neptune. I hope you've enjoyed it. It's been a lot of fun, and I really look forward to talking about the dwarf planets and go on from there. Please remember to share this and keep enjoying. Please don't forget to add questions in or anything like that. I look forward to hearing from you soon. Take care.